Physics notebook.
Okay, so here we go with the last lab that you will do in AP Physics.
Before we do the finals.
Yeah, well, the final, that's all we're gonna do. Okay, so here's the basic story of what you're gonna do. Is that you're gonna look at how submerging an object in different liquids affects the buoyancy and the subsequent tension on the string. So on the pre-lab, there's a couple of graphs that you kind of need to analyze, okay? And so the first one, let's kind of go through this to make sure everybody's cool. So sketch the predicted shape of graph where tension is on the y-axis, okay? And then you got the volume submerged on the x-axis. So let me kind of give you this visual. So right now, the reading on the scale is like 2.58 newtons. So, with none of it submerged, the tension on the string is up here at 2.58 newtons, okay? So I'm going to lower this into the water, so let's go about halfway. So when that's about half submerged here, half of it's below. What should happen to the tension on that string, Thatcher?
Decrease,
Why?
because buoyancy is also providing upward force.
Yeah, so buoyancy is acting upward. There's going to be less load on the string, and it's dropped down to like 2.45. So here's the point of this story. As I put more and more of that water, or that object below the water line, what's going to happen to the tension in the string? It's going to become less and less and less. So this line's going to go something like this, okay? More that's submerged, less tension that there's going to be. So on the second part, you want to do dimensional analysis to figure out the slope of a line if you use tension and AGH. Now, AGH looks really, really weird. It's like, God, what kind of jacked up thing is this? So, let me explain what this is. So, area is going to be the cross-sectional area of the bottom of the cube. Okay, so that's one of the things that you've got to measure. Oddly enough, that has to be in
Meters.
squared, right? Because it's going to be an area. So, you're going to have meters squared here. Then you're going to have G, which is going to be in meters per second squared. And then you're going to have a height in, now that height is the volume that is submerged, okay? So as you submerge this more and more and more and more, what's going to happen to the AG part of it? Stays the same. That's not going to change. If I submerge it, I'm not going to change the cross-sectional area, and I'm not going to change the gravitational acceleration. But if I put more and more and more of that below, as basically your variable is going to be h, so as more and more and more of that is submerged, that's like saying, hey, more and more of this is below the water line. So what you want to do is take tension, and tension is going to be measured in, and I would use kilograms meters per second squared. So you want to find the units for this slope. Remember, that's change in y over change in x. So you're going to have kilograms meters per second squared divided by meters squared times meters per second squared times meters. And you want to do dimensional analysis and see what you get out of that, okay? So, then you've got some questions to answer on that. So that's like the pre-lab part. Now, the heart and soul of the lab is over here on page 3. So you want to divide and conquer because you need like 4 sets of data. So I'll let you sort out who wants to do what. But you're going to have 2 different blocks. One block made of iron and one block made out of aluminum. Okay? The aluminum will be the one that's not rusted and is going to feel less dense. Iron, this isn't the highest quality iron, so it's rusted a little bit, especially over all the years. So that's how you can tell the difference between the two. So what you want to do is take this cube, and you want to make a mark at 1.5 centimeters and another one at 3 centimeters. And 3 centimeters should pretty much put you right at the top of the cube, if not very, very close to it. So I'm going to have Sharpies over there. So you're going to make a mark so that you know exactly what happens when you get to that depth. So you're going to have it hooked up like this to a scale. And then you're going to lower that in until that water line hits this depth. And you're going to record the tension on the string. Then you're going to lower it completely to the 3 centimeter mark, and then you're going to record that tension. Now your second column is going to be your AGH. So over here on page 2, this is where I tell you to calculate the area of the aluminum base and the area of the iron base, okay? And then you also need to determine just the weight of each block, okay? Without any buoyant force on it at all. Just, hey, what does this thing weigh? Like this is like 2.58 newtons or whatever that is. And the same thing with the aluminum. And I pretty much tell you, hey, go through this. So there's a couple of different ways you all can sort it out. You've worked enough with each other for 18 weeks. So if you, because you have to do ethyl alcohol, do not drink it.
What? Oh. No alcohol?
Do you want to get drunk and get yourself screwed over?
So what you need to do is take aluminum and put that in water, and then you need to take iron and put that in water. Then you need to take aluminum and put that in ethyl alcohol, and then you take iron and put that in ethyl alcohol. So if you want to have, hey, one group do the aluminum, so the other group do the irons, that's cool. If you want to say, hey, one group is going to do the water and do the aluminum and the iron, and another group do the ethyl alcohol and the aluminum and the iron, I don't care. Okay? It makes me no difference whatsoever in terms of how this plays out. If you're really hardcore and you go, I want to collect all of my own data, that's cool too. Okay? Doesn't make me any difference, just get the data. But now, here's one thing to be aware of. With the Sharpie, when you do that ethyl alcohol is a solvent on that Sharpie. So if you're going to use that Sharpie to make a mark, kind of get an idea where that is, because as soon as that ethyl alcohol hits that,
Well, there goes your Sharpie.
yeah, well, your mark's probably going to disappear, okay? So just be aware of that. So if you're using the Sharpie, you can also use a pencil if you want to, but if you're going to use a Sharpie, as soon as that, you don't have to worry about it in the water, because water isn't that good a solvent, but you do have to worry about it with that methyl alcohol. Yes, you have some graphs that you need to draw, okay? But the good news is the graphs only have like a couple of data points. So, anyway.
Hooray!
All right, I'm done. You're on your own. Be free.
All right.
Let's go.